Hello and welcome to the topic of sets and Venn diagrams. In this chapter, we are going to see what are sets and how we can draw Venn diagrams according to our needs of those sets. So let's get started. A set is a collection of well-defined objects. For example, let's say we have a set of prime numbers that are less than 10. Then it would include 2, 3, 5, and 7 as its objects. The methodology of writing sets is that they are written in curly brackets. Each object is separated by a comma. For example, if we were to make a set of vowels, we would go A, E, I, O, U. A Venn diagram, on the other hand, is the visual representation of sets and their relationships. So now let's talk about set notations. Set notations, or simply notations that are used with sets, tell us what each object or the element or a set actually corresponds to with the relationship to the other. For example, if we write n parentheses a, it would be read as n of a. It means that we are talking about the number of elements in any set A. For example, if set A is 1, 2, and 3, then it has 3 elements, and n of A, that is number of elements in set A, would equal 3. This epsilon like symbol or E like symbol signifies is an element of. For example, if set A was 1, 2, and 3, then 2 would be an element of set A, or 2 would be an element of set 1, 2, and 3. A simple line on that E signifies is not an element of. For example, 4 would not be a part of element set A. Simply, 4 is not an element of set 1, 2, and 3. This apostrophe written right next to the name of the set, read A prime or A complement, signifies that we are talking about everything other than what is set A. For example, if epsilon or universal set contains 1, 2, 3, 4, 5, and contains 1, 2, and 3, then A complement would contain 4 and 5. As the universal set contains 5 elements, and A set contains 3 elements that are also present in the universal set. So A complement would contain all the 2 elements that are not in the set A. A symbol of phi or not, that is basically an O with a crossed line, is signifies an empty set. It is also written as empty curly brackets. The symbol of epsilon or this curly E shows universal set. For example, an epsilon could be 1, 2, 3, 4, 5. This is a set of first 5 natural numbers, and A contains first 3 natural numbers. So universal set is simply the set that contains the entirety of the data that we are working on. Now let's talk about subsets and supersets. The symbol that looks like a C with a line underneath it shows is a subset of. For example, if we have two sets, that is A and B, and both the sets are such that all the elements in set A are available in the set B, then every element of A is also in set B. So we can say that A is a subset of B. For example, if our A set contains 1 and 2 and our B set contains 1, 2 and 3, then we can say that A is a subset of B. The same symbol with a line across it cutting it would say that it is not a subset of. For example, if A contains 1 and 4 and B contains 1, 2 and 3, then A is not a subset of B. A does have an overlapping element, that is 1 in both the cases, but 4 is not present in B, so A would not be the subset of B. Similarly, superset is the inverse concept. We could say in the first example, where A is a subset of B, we could also say it like this, that B is a superset of A. Basically, it contains the other set. In the second example, we could say that B is not a superset of A. Now, let's talk about unions and intersections. The symbol of union is written as a U, and the symbol for intersection is an inverted U. So, in case of A union B, we would write it as A U B, and it would be read as union of A and B. It means that elements in either A or B or both. For example, our set A is 1 and 2, and our set B is 2 and 3. Then the union of both these would be 1, 2, and 3. It is important to note that the repeated elements are not written twice in the union, they are only written once. In the case of intersection, we talk about only the elements that are in both A and B sets. For example, in A intersection B, we would say that elements in both A and B are to be taken. So if A is 1 and 2 and B is 2 and 3, so intersection would be simply 2. Now let's take a look at a Venn diagram. For example, if we have our universal set as the whole numbers, then we could say that we have two sets, A or B, and these two sets would be even numbers and prime numbers. We could also have more, such as odd numbers. But for now, let's focus on Venn diagrams with only two sets. The way to draw a Venn diagram is to draw a rectangle that would contain our universal set, and then inside we draw each set as a circle, and each set would have its elements. For example, the prime numbers that are part of the whole numbers would be 3, 5, 7, 11, 13, and so on and so forth. It is important to note that 2 is also a prime number. And in case of even numbers, we would have 0, 2, 4, 6, 8, and this pattern would continue so on and so forth. But since 2 is present in both in even numbers as well as prime numbers, it means that both our sets have an overlapping element. Now, this overlapping element is written in between both these circles that show each of these sets. It is important to note that if in any case that both the sets A and B does not have an overlapping component, then they would both be drawn as totally separate circles. Just like in this case where even numbers and odd numbers does not have an overlapping element. So they are both drawn totally separate from each other and does not have any intersection in between. In case we have three sets, in this case we are taking our universal set as all whole numbers from 0 to 10. Then we could write it in terms of its even numbers, prime numbers, and odd numbers. So we have four prime numbers that are 2, 3, 5, and 7. And we have five odd numbers that are 1, 3, 5, 7, 9. And we have five even numbers that are 0, 2, sorry, six even numbers that are 0, 2, 4, 6, 8, and 10. Now 2 is an even number and a prime number, so it goes to the intersection area of both the sets. However, the other prime numbers that are 3, 5, and 7 are also odd numbers. So they go into the overlapping section of these two sets, B and C, which are prime numbers and odd numbers. Odd numbers that are not considered prime numbers, which are 1 and 9, would remain in their own set of 1 and 9. Now, let's take an example of subset and superset. If our universal set are the all of the whole numbers, then we could say all our whole numbers contain all the natural numbers, and natural numbers are all the whole numbers except 0. So natural numbers would contain all the numbers, and in this natural numbers circle or set, we would have these prime numbers. All the prime numbers are natural numbers such as 2, 3, 5, 7, 11, 13, and this pattern would continue so on and so forth. So all the prime numbers are subset of natural numbers, and all the natural numbers are superset of all the prime numbers. Now let's look at methodologies for writing sets. The first method is roster notation. It is also called the listing method. We enclose the elements of the set within curly braces, and we separate each element with commas. The order of elements in this case does not matter. For example, if we were to say define a set A such that A is a set of first four natural numbers, then it would go 1, 2, 3, and 4. Written inside curly brackets, each element separated by a comma. Another methodology is the set builder notation, also called the rule method. In this case, we specify a property or rule that defines the elements of the set. For example, we use the format curly brackets, we write the variable, and then we place a bar or a colon and then type the condition for the variable. Let's take an example. We can write b is equal to curly brackets x and then place a bar and then write x is a prime number less than 10. So we are basically defining a condition for x, and x would become all the variables, all the numbers that satisfy this condition. We read it as the set of all x such that x satisfies the condition. So in our example where b is all the prime numbers less than 10, we would read it as b is the set of all x such that x satisfies the condition that x is a prime number and is less than 10. So the set b would contain values that are 2, 3, 5, and 7. Here are a few additional considerations. A set with no elements is denoted by empty curly brackets or a phi. Infinite sets use ellipses, which are three dots, to indicate a pattern that continues indefinitely. Basically, the pattern does not end. So, if we are to define C as a set of all natural numbers, then we could write it as 1, comma 2, comma 3, comma ellipses. So it would mean that this pattern continues. It means that our set C contains 1, 2, 3, 4, 5, 6, and this pattern continues so on and so forth. And lastly, we have cardinality. Cardinality is the number of elements in a set. Basically, if we are to take an example of set A, such that A contains 1, 2, and 3, that are three different elements, then the cardinality of A, denoted as bar A bar, or n of A, is 3. Let's do an example. For example, we are given a universal set that contains the first three natural numbers that are 1, 2, 3, 4, 5, and 6. And our set A is 1, 2, 3, and 4, and set B is 2, 4, and 6. So we are asked to draw a Venn diagram and find a union B and a intersection B. So let's do this example. First, we are going to make a rectangle, and this rectangle would show or signify our universal set, and hence we would put the epsilon in it. And now, since we have two sets, we are going to first find out the common elements inside these sets. In this case, they are 2 and 4. So now we can easily draw two circles that identify as our sets A and B. And in the intersection area, the central area of both the circles, we are going to put both these numbers only once each. So we write 2, comma 4 in the center. Now for set A, what we are left with is 1 and 3. We are going to write 1 and 3 in the non-overlapping area of A. And then for set B, the only remaining element is 6. So we are going to write 6 there. Now we are going to take a look at the universal set. And in the universal set, 5 is not in either of the sets A or B. So we write it outside both the circles but inside the rectangle that represents our universal set. That's our Venn diagram ready. And now we can move on to finding a union B and a intersection B. First, let's talk about A union B. A union B are all the elements that are in set A and set B. So we are going to read set A first and then set B. So all the elements there, and then we are going to write both the elements, even the overlapping ones, but only once. So we go 1, 2, 3, 4, and 6. In the case of A intersection B, we are going to find the elements that are common in both the sets. Or simply we can look at our Venn diagram and find the values that are in both the sets or in the overlapping part of both the circles. So we go A intersection B and then we write these two values in our A intersection B quest part. So we go 2, comma 4, and that is the answer to our question. Thank you for watching. That's it for this video. If you have any questions, please comment and then I would try to answer you as soon as possible. Thank you for watching. Have a nice day.